now we're on to the dreaded step 5. Step 5 is the most difficult step. So here's what you do. I would do it on the other side, just so that these lines are easy to find, right? So turn the thing over. Let's divide it this way. And we know that the center of mass is going to lie, and we're going to use the center of mass equation to figure this out. We know the center of mass lies somewhere on the line connecting this guy's rectangle and this one's rectangle down here, right? Center of mass of this rectangle. All right. Okay, so the center of mass lies on this line somewhere, right? Like that. And that line right there, I'm going to measure this, and you got to do this. That line right there, I'm going to measure is how far is that? That is 14.9 centimeters. Okay. So you're going to measure that, right? That says 14.9. Okay, and what I'm going to do here is I got to figure out this area. Okay, I'm going to call that area 1. I'm going to call this area 2. Okay, and I'm going to figure out what that area is, and I'm going to use the center of mass equation. Right, the center of mass equation is x center of mass is m1x1 plus m2x2 all over m1 plus m2, right? Only I'm going to use the areas for this. So to do that, I got to figure out what these areas are. So I'm going to measure this. This guy is 11.1 centimeters. And then this line here is, I can do this. This is 11.6 centimeters. So the area of this is 11.1 times 11.6. Let me see if I can darken that up a little. There we go. Okay, so the area of that top thing is 11.1 times 11.6. It's 128.76. And that's centimeters squared, right? Okay, so now let's figure out the area of the bottom one, the bottom. All right, here we go. This is 21.5 centimeters. And then the height of this is 16.2 centimeters. Yeah, so the area of this guy is 16.2 times 21.5, 348.3 centimeters squared, right? Okay. So now I'm just going to use this formula here. And I'm going to figure out how far the center of mass is from here. So the center of mass, let's say the center of mass is somewhere here, right? Okay, I'm going to figure out this distance, and this is going to be x, I guess x, what is this? This is x center of mass, right? Okay, is this. Okay, so now I'm all set. My x is equal to, and then m1 is this guy. I'm going to pretend like the areas are masses. So I'm going to go 128.76. And this guy from here, I'm figuring out how far it is from here, right? So this guy is 14.9 from there, right? And then this is area 2, right? But area 2 is 0 distance from that, right? So it's going to be 348.3 times 0, right? It's 0 distance from its own center because we're figuring out how far from the center of A2, right? Okay, and then in the denominator I've got 128.76 plus 348.3. Let's see if we can math that. All right, here we go. I'm going to go 128.76 is that guy, right? Times 14.9. Then I'm going to divide by parentheses, and I'll add these guys up. 128.76 plus this guy. And I get 4.02 centimeters. Okay, now this is the most important step of all. Okay, I'm going to measure where 4 centimeters is. Hey, look at that. I guessed pretty good, right? Measure this. This is 4 centimeters. That was close, right? Not quite exactly right. And write 4.02 centimeters. And make a little brackety thing so I know that you're talking about that little line segment right there. Say that that's 4.02 centimeters. Yeah? So do the calculation. Measure that where that is, right? And it should be close to where it balances, right? It's like, whoa. In fact, there's the center of mass right on the other side, right? All right. So that is the dreaded step 4. Or sorry, dreaded step 5.